Hello everyone, today I'll be going over the 2020 AMC 8 problem number 22 solution. The problem statement is, when a positive integer n is fed into a machine, the output is a number calculated according to the rule shown below. If n is even, return n divided by 2. If n is odd, return 3n plus 1. For example, starting with an input of n equal to 7, the machine will output 3 times 7 plus 1, which is equal to 22. Then if the output is repeatedly inserted into the machine 5 more times, the final output is 26. When the same 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? So now in order to solve this problem, we can work backwards. We notice that in order to get to 1, which is our ending number, suppose we started at the number n, which is the number right before it. What are the possible values of n such that we can go from n to 1? So suppose that n is an odd number. Then we notice that once we feed it into the machine, we would have 3n plus 1 is equal to 1, which is the resulting number. However, we notice that solving this, we would get 3n is equal to 0 and n is equal to 0. This is not a valid solution because n is not odd in this case. Therefore, we know that there's no such value of n such that n is odd and will result in a 1. Let's look at the second case where n is even. We know that n over 2 must equal 1 by the second condition. We notice that n is equal to 2. Therefore, one possible value that will get us to 1 from the second to last step is if n is equal to 2. From here, we can continue on. In order for there to be, for example, let's suppose that the number before 2 is an n. To find all the possible values of n, we do the exact same thing. If n is odd, then we know that 3n plus 1 must equal 2. In this case, 3n is equal to 1 and n is equal to 1/3. We notice that n must be an integer, therefore this value does not work. Looking at the even numbers, we notice that n over 2 must be equal to 2. Solving this, we get n is equal to 4, which is valid. Therefore, we can conclude that the number before 2 can only be a 4. Now let's look at the number before that, call that number n, and do the exact same process again. Now we notice that in order for it to be odd, we would have 3n plus 1 equals 4. We would have 3n equal to 3 or n equal to 1. This is a valid solution. For it to be even, we would have n over 2 equal to 4 or n is equal to 8. Both of these are valid solutions. Therefore, for n, we could have it as either a 1 or an 8. Now we have to repeat the exact same thing for both of these numbers. Let's look at 1. We notice that, to save time, we can notice that 1, we started over here. So we know the exact sequence that will unfold once we continue with 1. We would have to go through 2 and 4 before we get to the next number. For 8, let's look at the number 8. We notice that suppose n is odd. Then we would have 3n plus 1 is equal to 8. 3n is equal to 7, or n is equal to 7/3. This is not a valid solution. Now let's move on to if n is even. We would have n over 2 is equal to 8, or n is equal to 16. This is a valid solution. Therefore, we can let the next number from here be a 16. Moving on from here, we notice that from 4, we broke into 1 and 8. So we notice that from this 4, we must break into 1 and 8. So now let's focus just on the 5 and break that up. So we can have two options, 3n plus 1 is equal to 5, 3n equals 4, or n is equal to 4/3. This is not a valid solution. For the even case, we would have n over 2 is equal to 5, or n equal to 10. This is a valid solution. Therefore, we would have only one connection to the number 5. For the number 32, let's do this one last time. We have 3n plus 1 is equal to 32, 3n is equal to 31, and n is equal to 31 over 3. Not a valid solution. Looking at the even numbers, we would have n over 2 is equal to 32, n equal to 64. This is a valid solution. Therefore, this can branch off to 64. Now we notice at the end, after all of our steps and we've counted them, we would have 4 numbers. Summing up these numbers, 1 plus 8 plus 10 plus 64 will give us an answer of 83, which is answer choice E.